Good afternoon and welcome. My name is Charles Clancy. I'm the Senior Vice President and General Manager of MITRE Labs here at the MITRE Corporation. And it's my pleasure to welcome you all to our September edition of our Grand Challenge Power Hour event. We've been hosting these events really looking at the intersection of science and technology issues with emerging policy challenges and questions. And it's a collaboration between MITRE Labs and the Center for Data-Driven Policy at MITRE. Our topic today is space domain preservation. And I'd like to thank our keynote, our panelists, all of the organizers who helped put this together, and thanks to all of you for joining and tuning in and listening to what I think will be a very exciting, interesting discussion about the space domain. A few housekeeping reminders. This event is open to the public, is being recorded, and is open to the press. So please keep that in mind as you contemplate your remarks on the event today. Also, a quick shout out that MITRE is, of course, hiring. So if you're interested in any of the topics you hear about today, MITRE has people working on these problems and is interested in talking to you. So please reach out. You can check out our website or reach out to recruitinghelp@mitre.org for any additional help with identifying potential opportunities. So with that behind us, it is my pleasure to introduce our keynote speaker, Dr. Azita Valinia. Azita is the chief scientist for NASA's Engineering and Safety Center. She really serves as a bridge between engineers, scientists, technologists, and the medical community on a whole range of different safety issues that relate to NASA and NASA's mission. Before her current role at NASA, she was the deputy director for astrophysics flight projects and oversaw 20 different space science missions, including the Hubble Space Telescope. And she has a PhD in physics with a specialization in astrophysics. So Azita, we are honored to have you join us today and welcome you to give us some remarks.
Thank you, Dr. Clancy. It is indeed my honor and pleasure to be here giving this address. Thank you for the invitation. So for the next 20 minutes or so, I thought I will frame the problem in terms of civil space, specifically NASA human and scientific exploration missions. And I will also touch on R&D that is required to mitigate some of the risks associated with the space domain and its current form. And since I will be featuring some of the work done by my colleagues at the NASA Engineering and Safety Center, or NESC for short, I thought I'd just give a very brief introduction for those of you who may not have heard of us about NESC. It was established in July of 2003 in response to the Columbia shuttle accident. And it was set up to do independent technical assessment, analysis, and tests to resolve challenging problems for NASA's high-risk programs and projects. It is staffed by NASA technical fellows and their support engineering technical discipline teams. You're about 700 or so of subject matter experts at NESC ready to tackle very challenging problems. So with that, let me dive in, and if you could please roll the visualization for me. I'd like a landscape and historical perspective of the space domain. The video you're looking at is visualization of cataloged objects in low Earth orbit as a function of time from 1960 to present. And as you can see, over the past 60 years or so, the number of satellites are being launched at a very steadily increased, a rapid rate of, I think last few years, about 400 to 500 launches globally on an annual basis. And as a result, the orbital debris associated with them has also exponentially increased. Let me frame the problem for you by giving you some statistics. We know that currently, there are at least 20,000 objects of the size of a softball, about 10 centimeters that could destroy a satellite on impact. There are over 500,000 objects of the size of a marble, about a centimeter, that can cause significant damage to a satellite. And there are over 100 million objects of a size of a grain of salt that could puncture an astronaut's spacesuit. And moreover, the growing volume of orbital debris threatens the loss of important spacecraft applications in our daily lives, such as weather forecasting, telecommunication, and GPS, that are really dependent on a stable and safe space environment. So on this chart that you'll see, I'm going to do a deep dive showing you the details of what you saw in the movie. And by the way, all these data and the movie that you saw are courtesy of the NASA Orbital Debris Program Office. So on the left-hand side, if you can, I hope you can see the details. What you're seeing on the bottom is the number of objects greater than 10 centimeters in low Earth orbit. And on the vertical axis is the number of those objects. And it is broken down by, the type of bodies, rocket bodies, mission-related debris, spacecraft, fragmentation debris, and the brown curve on the top is the total of those objects. I want to bring your attention to the magenta curve, the fragmentation debris. Notice what happened in 2007. You see a sharp vertical line. That is when in 2007, China conducted an anti-satellite test, destroying a defunct weather satellite, causing thousands of debris into low Earth orbit. And then you see another sharp rise in 2009, when actually there was a collision between a defunct Russian satellite and an operational US Iridium satellite. So here's the problem that we are dealing with. It is not just the sheer number of spacecrafts that are being launched by governments, by commercial sector, by nonprofit organizations, even students who are now launching their experiments in the form of CubeSats into space. It's also that other affect the orbital debris growth caused by the sheer numbers through collision, explosion, and so forth. So what I want to bring your attention now is the chart on the right-hand side. It is really important to be able to project and model the state of low Earth orbit into the future. The model that you can see is done through Monte Carlo simulations and is projected over to the year 2210. The left black curve that you see is the historical population that I just showed you on the left-hand side. But what you see on the right-hand side, there are three scenarios. The top one, the red curve on the top, is a modeling projection assuming no mitigation whatsoever into the year 2210. And then you see two other scenarios. There is the dashed black line, and that assumes a mitigation strategy of having 90% post-mission disposal of spacecrafts that are done with their service. And it takes explosion into account. And then the lower one, the dotted blue one, also 90% post-mission disposal with no explosion, meaning that we have added mitigation strategies for spacecrafts avoiding explosions. So I want you to remember this chart as we are talking, because this type of modeling and projection will enable us to decide on the best course of action for space domain sustainability. Next chart, please. So I'm going to start with the most obvious threat, the threat of collision. And what you see here, I have some of NASA's high-profile assets on this chart. First and foremost, the International Space Station in the middle. It is a platform for humans that live there every day and conduct an array of biological and physical sciences experiments, as well as medical research. And what you may have not known as an astrophysicist, let me point out that there are some really cool experiments also on the ISS, including an experiment called NICER that is studying the black holes and neutron stars. Now, on the right-hand side, on the top right, I have shown you the fleet of Earth observing systems, NASA assets. These are a constellation of spacecrafts that take measurements of vital parameters of the Earth environment, and they are absolutely critical in our climate change research. On the bottom, you see the fleet of heliophysics systems observatories that NASA has in orbit, and they are absolutely important in terms of helping us forecast space weather and protect our astronauts who are in orbit from solar particle events by warning them about taking shelter when the space weather gets pretty bad up there, and also to protect NASA assets. Now, what I want to mention is that these satellites are one of a kind, unique observatories. Having worked in the R&D community at NASA, I can tell you it takes decades to develop each and one of them, from concept formulation to technology development to validation of the technology in space and finally launching them. So I want to stress, as you can imagine, it would be a very bad day for any of these that will take decades to develop to be lost by a collision. And then finally, on the left-hand side, the astrophysics fleet. The most famous of them, I think you all know, the Hubble Space Telescope, still up there and going strong after 30 years, and also the fleet of the planetary missions that NASA is conducting. So let me go to the next chart and just remind you of a near miss incident. Next chart, please. Near miss incident between Starlink 44 and the European Space Agency's Aeolus satellite. Now, for those of you who may not know what Aeolus is, it is a cutting-edge mission. It's got the first Doppler wind LiDAR instrument that can take global measurements of the wind in terms of both speed and direction. And it's a very important piece of instrument giving us those measurements to put in our forecasting model to be able to predict the path of hurricanes and cyclones. It took at least a couple of decades to develop this mission. And so it would have been a very tragic day only after 1 year after it got launched to have been taken out by Starlink 44. Now, there was a communication glitch between SpaceX and the European Space Agency. And in the end, what happened is that it was ESA, the European Space Agency, that had to move the spacecraft out of the way by maneuvering. This example shows the urgent need for proper space traffic management, clear communication protocols, and more coordination, as well as autonomous collision avoidance software systems and artificial intelligence. Because with the advent of mega constellation, it's becoming clear that the manual approach of maneuvering and avoiding collision is no longer possible. So a lot of R&D actually is needed, and as well as a lot of policy and coordination. In fact, NASA and SpaceX entered a Space Act agreement regarding collision avoidance in March 2021 to prevent situations exactly like this. Next chart, please. So besides collision, the damage caused by orbital debris also is a big problem. Here I am just giving you a few examples. On the top left, you see a window crack from shuttle orbital debris impact STS-007. In fact, it was concluded that a speck of paint was responsible for this crack. And the window on the shuttle, it's not the first time that it had to be changed. It happened a few other times. On the top middle, you see the damage done to the antenna dish of the Hubble Space Telescope. To its right, the damage from orbital debris to the STS-092 vertical stabilizer. On the bottom left, the damage done to a Solar Max experiment, and the bottom two right pictures, the damage to the ISS radiator panel. In fact, the threat from orbital debris is one of the highest risks that could potentially in scientific robotic missions. And so next chart, I want to actually tell you what is the R&D that is going into trying to minimize the damage from orbital debris such as this. So if you could please roll the next chart, I want to talk to you by illustrating case study on the Mars sample return. So to set up the problem, let me tell you, I'm sure many of you have heard NASA's latest rover, the Perseverance, that is currently on the surface of the Mars, along with its sidekick, the helicopter Ingenuity. I'm sure you've heard of that. But this is a selfie, actually, of Perseverance. What it's doing right now, it is drilling holes in the rocks and taking samples out of the rocks and then caching them into a sample tube that you see right at the bottom left in that picture. What's going to happen in the next few years, Perseverance is caching these samples and then putting them on the surface of Mars. And a few years later, there will be a mission called Mars Sample Return, where a fetch rover will go, pick up those samples, put it on a Mars ascent vehicle, and bring it back to Earth. Now, this capsule returning Mars sample to Earth requires unprecedented micrometeorite and orbital debris risk assessment and shielding protection prior to being cleared to land on Earth. And the reason for that is the possibility that there could be organic matter in the soil. And having been through 18 months of a pandemic, I don't think I need to explain the planetary protection laws, that we need to be absolutely certain that there is no chance that that capsule could have been compromised during its descent to Earth. Now, it's going to be a mission spanning many years. The last 3 days of the mission, when its true final approach, is the one that is the most important in terms of orbital debris. Most of the time, we have to worry about micrometeorite, but during that last 2 hours, when it's on the path to Earth, we need to be absolutely certain that the capsule has not been compromised. And so I am featuring a work of one of my NESD colleague, Michael Squire, who's the principal engineer. And he and his team currently are doing a lot of finite element modeling of the Earth entry system and hydrocode simulations of the shields. And this information and the research that they're doing is going to help them come up with the absolutely robust shield design and also monitoring technologies to make sure that the capsule has not been compromised before landing on Earth. Next chart, I want to talk about one other problem. Being an astrophysicist, I couldn't possibly tell you what's happening in the astronomy community. The image that you see in the middle is an image of the sky taken at the Lowell Observatory. And those diagonal lines that you see are the light reflection from Starlink satellites that was launched by SpaceX. Now, to a non-astronomer, this picture may look really cool and fascinating. But let me tell you, for an astronomer, Starlink satellites photobombing the image from the universe that astronomers are trying to study is not cool. And in fact, they are pulling their hair out, trying to find mitigation techniques. For example, software fixes to take the trails out, but a lot of it may have to come to R&D. SpaceX, in fact, has been actually very willing to work with the astronomers. They tried to lower the brightness of the satellites by darkening, but obviously that didn't go very far. It only helped halfway. And so they're also thinking of other techniques, such as adding a sunshade to the antenna. To lower the brightness. Now, even if you don't really think much of the astronomical community and the observations and their scientific research, let me tell you that this actually has profound ramification for us in terms of planetary defense. Because if we get to a point that our view of the heavens is clouded through either optical or radio interference, because a lot of these near asteroids that we're tracking, both in optical and radio, there's a lot of potential interference, and there could come a time that we might not be able to see what's coming at us. And that really highlights the importance and the potential problems that we are dealing with and the mitigation approaches that we need to take. One more chart. So far, I really, all I have talked to you about is problems and problems and their problems and R&D fixes for that. To mitigate the damage. But there's one other approach that I want to talk about, again, featuring the work of my NESC colleague, Michael Squire, who has been really working, he and his team, on preventing additional debris in terms of spacecraft passivation techniques. And what that really means is that we are trying to limit orbital debris through depleting stored energy in decommissioned spacecraft. And there are two approaches that he has been working on. One is the electrical power systems to reduce the potential for battery overcharging and fragmentation events, and also recommending pressure vessel venting targets to reduce the possibility of overpressurization and fragmentation from micrometeorite or orbital debris impact. And so he and the group are coming up with strategies for NASA standards for acceptable targets for both the pressure vessels and the electrical systems. So that really concludes most of what I had to say, and I'd like to leave you with a final thought here. The ultimate mitigation strategy that is on everybody's mind these days and everybody's talking about. So the risk mitigation activities alone may not really be sufficient to stabilize the safety of the space domain. And if you recall the chart that I showed you at the beginning, showing you the models into 2200, you'll see that some studies, and I showed you one of them, really shows that the growth of debris in low Earth orbit can be slowed by ensuring that at least 90% of all spacecrafts are removed from orbit within 25 years of the end of their mission. And so we may need to think about game-changing technologies at this point. I recall we started talking with NASA colleagues at least 10, 15 years ago, talking about trash sats that is entering the popular domain these days. We really need to come up with, in order to ensure the sustainability of the space domain, we need to think about active debris removal. And so I am going to leave you with that, knowing that this is not a problem that only one government can solve, or one industry can solve, or even one nation can solve. It requires a lot of coordination on a global scale. And with that, I thank you for your attention and hand it back to you, Dr. Clancy.
Excellent. Thank you so much. So on your last slide there, the idea of trash sats, I think, is an interesting one. And I mean, the European Space Agency has, for example, put in place a plan to launch what they're calling Clear Space One, I guess, in a few years. But is there sort of an economically sustainable approach to this? What should the economics incentives be, really, to help clean up after yourself, if you will, in low Earth orbit?
That's a great question. And let me tell you that I compare the economic incentives with the current economic incentives we have for sustaining our own environment in terms of carbon emission caps, right? There are plenty of incentives for industry and for people to reduce carbon emission. And I think that could definitely apply to the sustainability of our space environment. Now, I am no policy expert, and I'm looking forward to hearing the panel discussion, but I think there's definitely a case to be had there.
So I think the environmental analogy is an interesting one as we think about how we as a species effectively serve as stewards for the space, much in the same way that we do for the environment of Earth. If you think about the climate analogy, right, many say there are these sort of average temperature increases that will start to have a cascading effect on our climate. In low Earth orbit, one of our attendees asked a question about the Kessler effect, which is the idea of cascading impacts in orbital debris, essentially making entire orbits not useful. Is there a sort of a 1 to 2 degree increase threshold sort of analogy that we have in the climate space that would put us at a tipping point, if you will, in terms of orbital debris and sort of cascading amplifications of that debris?
Absolutely. And if you see in the climate models and the projections that you see, there is a tipping point, right? Where if we don't mind the problem, it may be too late. And the same thing with the Kessler effect that was brought up, an excellent point, where the theory is that it might be, if we get to that tipping point, that we may not be able to use the space as we do today in hundreds of years, because the problem will completely get out of control. So I definitely see those analogies, and actually that's some area that the two communities can learn from each other in terms of breaking the silos.
I wanted to go back to another point you made around this idea of lowering the brightness of Starlink, for example, by darkening them. We also, of course, have the dual challenge of needing to maintain detailed knowledge of ephemeris for the spacecraft that are in orbit, so that we can effectively kind of do the traffic management. So how can we do the traffic management if we can't see the things that we're trying to track? There's a trade-off there, and what do you think about the balance between those two things?
Exactly, and that's an excellent problem that we need some engineering trade studies. And that is when communities like the satellite operators and the astronomical community really need to start talking to each other. And probably the interaction is not as great as much as we would like it to be. I think it is beginning. The astronomical community and SpaceX are engaging. And so we need more of that to find that best sweet spot of where we need to go in terms of R&D that's needed to tackle these problems.
Right. And just a reminder to the audience, please feel free to submit your questions, and I will moderate and make sure we get them all asked. From a broader sort of space safety perspective, I know many of us were watching the news about a month ago when the ISS lost attitude control because of a thruster misfire from a new Russian research capsule that was added. And it was sort of, I don't know, remind me of definitely scenes from various sci-fi movies about losing control in space. And I'm wondering, that's a sort of a scary proposition, both certainly for the astronauts that were on board, but also for I guess things, space safety more broadly. How do we think about trying to avoid having those sorts of things happen again in the future, and what risk does that present really to things in orbit overall?
Right. Great question. In fact, there has been occasions where the ISS had to be maneuvered out of the way because of orbital debris. And so there are processes there to ensure the safety of the astronauts. One of them is to take shelter in Soyuz or commercial vehicles and just be ready to leave. And so that is one of those scenarios. A lot of planning, obviously, is underway, and there are scenarios for every situation. And so I think the good news is that they were prepared when that incident happened, because they had to deal with other similar issues in terms of orbital debris. But it's a continuing learning experience, and planning and learning and more R&D all the time.
Yeah. Another audience question is really interested in exploring this idea of trash sats a little bit more. The spacecraft I mentioned, Clear Space One, I guess, is using these sort of mechanical arms to reach out and grab things. But are there other sorts of technologies, kind of like I don't know, nets for garbage nets kinds of things? Could you talk a little bit more about the sorts of technologies that might be appropriate for these new trash sats?
So actually, the ClearSat, the Clear Space One that you mentioned, if you go on their website, there's actually a very nice animation. So please go and take a look. And that is really the only technology demonstration concept that I am aware of. I think the R&D in that area is still in its infancy. And that might be a good, really, panel discussion to come in terms of how do we give incentives to coming up with these technologies, or encouraging technology development in these areas.
Okay, excellent. So another one of our audience questions was kind of looking at the other side of the coin here. Rather than removing debris from orbit, how can we perhaps get more reuse out of the things we're putting into orbit? Certainly, SpaceX has pioneered a lot of reusability in their Falcon 9 platform. Are there other opportunities for, if we think about reduce, reuse, recycle, right? Again, to the climate metaphor, is there some more opportunity for reuse that we might see in orbit?
Yeah, I think you're hitting on satellite servicing, right? Refueling when they run out of fuel, or fixing it up. Think of Hubble Space Telescope, right? When it was launched, nobody thought that it was going to last 30 years and some. And it's not because it went on its own. It had to be serviced, right? At least 4 or 5 times. I'm losing count. So that is a good point. And I think there is merit to that. As long as we come up with mitigation strategies like I was talking about, that those satellites do not fragment and make a worse problem in low Earth orbit.
Right. Interesting. So we've been talking some about really trying to, well, you mentioned that SpaceX was really with Starlink and the density of spacecraft, we're seeing really an increase in the near misses, or also known as conjunctions. And part of that is that we don't always know precisely where every single satellite is. There's always some error associated with our ability to measure and track and maintain situational awareness on precise locations. I wonder if we could take some lessons learned from the aviation community, where you now have active transponders on aircraft that are providing precise location using technologies like ADS-B. Is there an ADS-B for low Earth orbit that we should be thinking about?
Absolutely, and that goes along the line of talking to different communities and learning from that. The aviation industry has nailed it pretty well. Once in a while, we hear about near miss occasions, but I think there is a lessons learned there, and what I talked about in terms of artificial intelligence and autonomous collision avoidance systems. That is definitely something that we need additional R&D, because think of it, SpaceX has applied for a permit of over 30,000 of these, and they are not alone. There's the Amazon Kuiper project, and there are other projects that are going to be thousands and thousands of these satellites. And so that really, to your point, we really need to have this advanced AI technology nailed for these applications.
Yes, indeed. Certainly, the more autonomous these platforms can be, the more they can self-maneuver and deal with some of these issues in real time. All right, well, I think we have asked, I think, the majority of the questions here from the audience. So I want to thank you very much for taking the time out of your afternoon to come speak with us. It was a fascinating discussion. And with that, I would like to transition over to our panel. So up next, we have Dr. Ben Poole. Ben is the Chief Engineer and Acting Managing Director for our Space Warfighting Division within the Air and Space Forces Center here at the MITRE Corporation. So I'm excited to hand the baton off to Ben for him to continue with the moderation of the event. Thank you.
Excellent. Good afternoon, and thank you, Charles, and thank you, Azita. I think that the talk that we've had so far has really highlighted the significance of the change that we're facing in the space domain. The congestion is really especially in LEO, is significant. The stand-up of U.S. Spacecom and the U.S. Space Force also highlight another significant change in the domain in that it is increasingly contested. And finally, the number and the types of operators that we're seeing is growing significantly. And so now we have, some elementary schools that have put up and are operating CubeSats. These changes are raising questions about the nature and safety of space operations in the future. So here with us today, we have a panel of experts to discuss the preservation of the space domain. Kevin O'Connell is the former director of the Office of Space Commerce, where he helped focus the Department of Commerce's efforts in response to Space Policy Directive 3. Since leaving the government, he is running Space Economy Rising, LLC, an advisory firm that is focused on all aspects of the space economy. He continues to work in support of U.S. space safety and sustainability initiatives, including work with the international community. Dr. Darren McKnight is a senior technical fellow at LeoLabs, where he contributes in a wide range of capacities. From data algorithm development and radar sighting studies to statistical collision risk assessment and partnering with academia, Darren strives to apply a global context to the growing LeoLabs space safety solutions. And finally, Sean O'Neill is a technical fellow with MITRE with over 35 years in radar and sensor signal and domain and data processing. Most recently, he has focused on sensing for space domain awareness and currently leads MITRE's corporate initiative on preservation of the space domain. This initiative is focused on developing an understanding of the risks to space as an ongoing part of the global economy and infrastructure, and fostering consensus on government, coalition, and commercial means to mitigate those risks. So we've got a set of questions teed up for our panelists here, and so Kevin O'Connell, I will ask you to please be our first responder to the first question. What are the key things that your organization is doing to address the significant change we face in the space domain? And what challenges do you worry remain unaddressed?
So Ben, thank you to you and Charles and the whole MITRE team for the invitation to be here with you today. This is obviously a topic that I spent some part of every single day while I was at Commerce. And as you just mentioned, in the 8 months since I've left, I've started this advisory firm, Space Economy Rising. And it has become a topic that has become of interest across a wide range of, we'll call them stakeholders. Everything from the finance community that is investing in space activities to states and new jurisdictions that want to participate in the space economy, and in particular, a number of innovative companies that are operating in this space. Space, the bottom line on space is it's playing an ever important role in our lives. Some of you may have seen the testimony that I gave before Senate Commerce on 22 July, which was really focused on this issue of space traffic management and space debris, et cetera. But I actually started in a different place when I talked about the rise of the space economy. And, I used words like accelerating and diversifying rapidly. I talked about the fact that, we'd all lived through, and I suspect this audience very much has all lived through their day without space exercise over the last 20 years. And I think we're actually moving fundamentally away from that view to one where we realize that space is really becoming a key platform, maybe the key platform, which is going to fuel all of the innovations that we expect and need over the next decades. Ag tech and clean tech and ed tech. Was on a very interesting webinar yesterday on the nexus between ESG goals and space activities. And there's a very, very nice fit for lots of reasons, in many cases having to do with the data that can be uniquely captured from space. And so, we've moved quickly from a world in which we were talking about remote sensing and communications and navigation, all of which have had tremendous advantages, or advances, I should say, in their own right, to a world now where we're talking about space medicine, and we're talking about data centers, edge computing, and blockchain, and we're talking about the cislunar economy, and real activities taking place, either experimentally or otherwise, to move in that direction. So it's really affecting our lives in many more ways. So why do I start there? Well, of course, it's all at risk. If we don't make progress on the topic that we're here to talk about today, preserving the space domain, absolutely critical. I think Azita used the term "bad day." I've used the same phrase in some of my remarks historically. You'd have a very bad day in space, if you have major collisions. We talk about the Kessler effect, but I think in addition to that, obviously, she mentioned the threats to the ISS, and that's top of mind for everyone. The human exploration of space, that's going to grow as more and more people go into space, and so that's our top concern. But I'm also concerned that we're also going to start to see a dampening of the effects of commercialization in space. Charles talked about economics. I'll come back to that in a little while, maybe during the question. And so we may actually see if operators have to add fuel or add mesh or do a wild number of maneuvers to stay out of the way of space debris, that could dampen the effects of commercialization. So a couple other things that I've been doing since I left. Number one, I continue to work with a number of companies that are working specifically in this area of space safety, space sustainability. There's a great many number of companies, both out of the space community, but also from a broader technology community that are working on things like analytics and visualization, that are working on cloud computing approaches, to the points that Azita made, companies that are working on autonomy for space systems, the role of artificial intelligence. All of this is in the market. People are working on these today as we speak. And so there's increasing interest in the active debris removal as well, as companies are bringing newer, lower cost activities into the market. And so active debris removal has always been one of the tools in the toolkit. It's the economics of that that's changing. And the other point I would foot stomp from the question that Charles asked was, In terms of SSA, people often ask me, why did you spend so much time on that at Commerce? And I assume that's continuing. But the reality is, if you don't have highly exquisite SSA, much more timely, precise, and accurate understanding of the space environment, you cannot effectively do STM and you cannot effectively do active debris removal. And so that's a key enabler of all those other things. Second thing I did was I joined the Space Enabled group up at MIT, where there's a special emphasis on space sustainability. Under Professor Danielle Wood's leadership, students take on research topics in this area. And the Space Enabled group also played an important role, along with other academic and industry partners, in developing the space sustainability rating that you may have read about. That's a voluntary approach that actually space operators can use to test and demonstrate their own role in space sustainability. And then finally, just like participating in events like this today, I'm working with AIAA and SIA and a number of other organizations who are trying to bring additional clarity. This is such a complex topic in so many different ways. It's complex technically, it's complex organizationally, it's complex internationally. And so we have to sort of take pieces of this one part at a time. And try to shed some light on the key decisions that have to be made and then how they interact with one another. And so that's how we've been spending some time in the time since leaving Commerce.
Excellent. Thank you, Kevin. Darren, do you mind taking and providing us your thoughts? And I'm happy to repeat the question if you'd like.
Nope. I got the question, especially with Kevin's answer. So I really want to heap on to what Kevin said. I work for LeoLabs, and I like to tell a lot of people that I'm not really interested in opinions when facts are available, because that's what LeoLabs is all about, giving you new facts. We are building a global network of radars. We'll have a couple S-band radars on every continent in the world other than Antarctica within 2 years. We currently have 6 radars available. We take more measurements than the Space Surveillance Network does on a daily basis. And there's 3 things that we really want to focus on, and they resonate with Kevin very specifically. Number 1, we need to provide accurate space surveillance data. What I mean by accurate is the how close 2 objects come to each other. To be able to do that well, you need to be able to, 1, observe the object where the satellites, and 2, have the least amount of propagation time. I'm talking a little more technically than some of the other speakers, but again, I want to make sure we get precise here on the benefits. So if you see an object more often, you propagate less time, the covariance is less, the probability of collision is more accurate, and it will prevent operators from having to maneuver. Dave Goldstein from SpaceX announced at AMOS last week that we are providing collision avoidance for them. He also said they do collision avoidance 12 hours out for time of closest approach. That is not standard. LeoLabs provides information that allows things to change the way you do business. It used to be, we'll look at 7 days, at 3 days we have to move because the conjunction data messages are given out every 8 hours. That's the way it was typically done. Anytime an object crosses one of our radars around the world, within 10 minutes, we issue new CDMs, okay? It's just like if you want to follow the stock market, do you want to read the stock price every morning, or do you want to be online and looking at the stock ticker? We're the stock ticker, not looking at the Sunday paper, trying to figure out if you're going to move some stock. The second thing you need to do is be more precise. The actual objects that you can see. Azita talked very, very eloquently about the lethal non-trackable debris, we called it. The objects between, say, 1 centimeter and 10 centimeter, you can't see them with radars currently, but they can kill you. All right. So the trackable debris environment, we issue a conjunction data message, either us or the 18 Space Control Squad, who does the same job. If they issue a conjunction data message, great, I've avoided space debris collision. Yep, you've avoided 2% of the mission terminating risk. The other 98% of that mission terminating risk is still out there. We're living with it. And that brings on the last thing that LeoLabs data does for you. It gives us a chance to build like a heartbeat of low Earth orbit. There's a couple of papers that we presented at AMOS last week that I make available to the organizers for everybody who's listening. But basically what we did, we looked at 1.4 million conjunctions over a year's time. Forget about models. Remember what George Bach said about models? All models are wrong, some are useful. We want facts when we can have facts. We generated facts. And what it showed is that the debris generating potential Debris generating potential is probability of a collision times the consequence, where the consequence is the mass of the objects involved, because that consequence is how much more debris is going to be created. We did that mapping for all of low Earth orbit for a full year, and here's what I can tell you. 2/3 of the risk comes from dead things. Only 1/3 comes from these satellites, the operational satellites, these constellations. People like to say the M word in front of constellations. I won't say that. People know I won't say that word, because if it's a large constellation or a small constellation, how bad it is how it's operated. How carefully they listen, how much they pay attention to the new data, how much they embrace the new data and the new concept of operations. So a full 2/3 comes from dead objects. So what are these dead objects? These dead objects are rocket bodies, dead payloads, and fragmentation debris. What we also found out from this last study, which actually resonated with other studies that have been done, Russian rocket bodies, bad. They have been abandoned in clusters of objects. They're just as tightly bound as some of these constellations, except they're bigger, dumber, because they have no collision avoidance capability, no intent to avoid. And if a collision occurs, they're 10 times, 100 times as massive. But what's really interesting, if you look at the worst place, so I'm a space realtor for a moment, folks, don't go to 850 kilometers. Location, location, location. Right in that region are the most massive Russian rocket bodies with Chinese debris and abandoned U.S. payloads and some abandoned and also some U.S. debris fragments. It's unfortunately a uniquely ironic collaborative effort to make a mess of low Earth orbit, and that's a bad location. So again, what we do is try to provide more precise, accurate updates for specific collisions, and then do a mapping of all low Earth orbit to look at that statistical risk. And so that balance is exciting. And I'm very new to LeoLabs, and for 40 years I've been working this problem. And it's the first time where somebody's paying me for use the best source of data available. So it's very exciting, and I think we can do a lot to enhance space safety.
Excellent, thank you, Darren. Yeah, and I resonate a lot with your one of your earlier points in particular about that the changes that we talk about in the domain are not limited just to what's going on in space. What needs to change as well are the processes that we use on the ground, and those fundamentally need to change to be able to get ahead of what we're facing in the future. Sean, do you mind providing a response now, please?
Sure. Well, first let me say it's a real honor to be on this panel with Kevin and Darren, both of whom I've talked to several times. And really, I kind of want to just follow on with what they've said, because they've been very eloquent about outlining some of the great benefits we get from space, but also some of the real challenges that face us in the coming years. And just to directly follow on with something Darren was going on, space itself it's really not that crowded when you think about how many collisions we've had. The problem really comes down to a question of information. It's the uncertainty bubbles around everything that cause the problems. And that's where we really face our challenges. And so, so there is a lot of really good work, I think, going on in a number of sectors within the government, in building better sensors to look at things, in the commercial industry, such as LeoLabs and other folks who are building radars and telescopes to increase our ability to understand what's happening out in space. And the bottom line is we just need a lot more of that capability to get to where we need to go. Now, that being said, that is not enough. And I think everybody understands that, because it's one thing to have good information on what's happening out there, or certainly on the things that we can see out there. And as has been pointed out, there's a number of things that get increasingly challenging to see. So especially, the objects between 1 and 10 centimeters. But we also have to think about how it is that we organize our activities in space, how we allow people to go into space, what kind of incentives and regulations that we put on them, and how we set the rules, how we adjust those rules, how we decide who gets to go up into space and who gets to go at what orbits. Right now, the only orbits that we allow people, where we have really direct control over, that we specifically allocate, is at GEO, and that's because of the ITU. We have nothing like that for low Earth orbit, and then that's where most of our issues currently sit. So how do we deal with that problem in the coming months, years, decades? I will note that right now we have SpaceX, which is putting up a number of objects in space, and it's not, as we said, space is large, but SpaceX's satellites are mostly going in the same set of orbital planes and same set of altitudes. And so just like, the traffic jams only occur in particular locations in the downtown area, that's where all your risk of cars colliding is. The same thing is going to be true of collisions. So, where these large constellations set up, as well as zones like Darren noted, like 850 kilometers altitude, those are going to be risky until we do something to either mitigate it or prevent people from squatting at those altitudes, or prevent too many people from going into those particular orbits. So, what are we thinking about here at MITRE? Well, I think in conjunction with the things that Darren and Kevin noted, we're really worried about sort of the governance of space. In other words, how are we going to set the rules in the future time for commercial space actors? How are we going to come up with norms and agreed upon modes of operation between spacefaring nations? How is all of that going to occur? And, thinking about just the problem writ small, as it were, with the United States by itself, just thinking about the challenges that face us in terms of governing, how do we properly incentivize U.S. companies to adopt good behaviors? How do we get them to, for example, if we wanted something as simple as tell us at some cadence where your satellites are and what your plans for maneuver are. That seems like a relatively easy thing, but as we sit here today, we're still a long way from that happening, from that information being shared to everyone. And that's really valuable information because nobody knows as well as the owner operator typically where their satellite is and where it's going to go. But it's understandably so, people don't necessarily want to share that information. So we're concerned about that. We're concerned about actually some of the messages that Congress sends as they try to set directions for how we govern space. So, who Congress decides is in charge of what component of space sends strong messages, and how they end up funding those various directions that they put out send strong messages. And so it's important that Congress really understand the importance of space and the importance of getting the governance of space right, and they proceed in the right direction. So we're very concerned about informing our members of Congress about what we think the important issues are, and what the options are, and what kinds of things need to be followed through on. Beyond that, I think we're really concerned about really informing policy from a larger perspective. So I'll give you an example of that. We think there's a really good case to be made in often that we would benefit from greater releasability of data. Those people who are familiar with how the DoD operates its space surveillance network and how it operates spacetrack.org and creates the catalog know that a lot of the information that the DoD has and that is important to understanding what's happening in space domain is very hard to get a hold of. We often only share up to a certain point, even with our closest allies, and that's because of the rules that we've set up. And I think in many cases, we need to look hard at those rules and think about, what information could be shared more broadly, not only because of its utility, but also because it sets an example to the rest of the world. Often, if the U.S. does it, the rest of the world tends to follow suit. And follow one last thing I'd like to add to all of this. You asked about, what kind of changes remain unaddressed. I would say I don't think people are focusing enough on the issue of wherever there's a system, a highly complex system, there's just by human nature, there's a set of people who like to go gum it up. And so I'm worried about the future script kiddies of space, for lack of a better term. It is that without proper governance, there's going to be lots of opportunities for people, not necessarily state actors, but people just because they want to, it's human nature to want to gum things up, that they can do something that can have a large impact on our capabilities in space. And so I think that's something that we need to think hard about and especially think about it as a driver for why we need to develop some of these structures.
Darren, do you want to jump in on that cyber topic there, or?
So Ben, I said
not just cyber, I should add. It's everything.
I said I wasn't going to do this if you gave me the option, but I think Sean brought up something really important I wanted to follow up on very quickly. And Sean, your comment about data availability is really critical, right? And so I just want to make sure people understand that the way we run our system, you actually know exactly what radars contributed to every observation, and you also know exactly what the covariance is when you get your conjunction data message, and all that can come up on your phone in real time. Because you're exactly right, Sean. People won't feel good about it until they have it. That includes the operator ephemeris for the folks who are using our service. And we put the 18th on there, just like the weatherman says, the hurricane's coming. Here's a European model and here's a US model. We put all of that data onto the same interface, so you get a feel about both of those situations using operator ephemeris. And we've even had the opportunity to work between two operators in that sharing. So I think it's important, Sean, like you said, to break that down. And you know something? It is not about technology. It's just about people. And I would tell you that a lot of folks have talked before about, well, OneWeb and SpaceX didn't talk. Well, guess what? That one event makes it, they talk more. They talking to John Guinea from OneWeb in a webinar the other day. He goes, I talk more to SpaceX than my wife. Okay, so he said it, not me. And so so they really are communicating very closely. I think people are doing the right thing. But the stories, you get headlines by the one event that didn't go well. But the real headline is they're working very closely, and a lot of that data is being shared. But it's a great point, Sean. Thank you for bringing that up.
So Darren, maybe you can kick us off with pulling the thread maybe a little bit more on kind of our next question. And so, and I think we've hit on this a bit already, but let's maybe unpack it a little bit more. As you think about operations in the proliferated domain, what do you need from other space operators to effectively conduct your missions in a safe manner?
So Ben, I was so looking forward to answer this question, and Kevin and Sean are going to love following me on this. I'm going to say the thing you need to do is stop listening to old regulators who are living in the 90s. Okay, so let me be a little more specific about that. Most of the operators of constellations right now are not living up to the ODMSP. They're much better. The ODMSP, the Orbital Debris Mitigation Standard Practices, right? And that often proliferates into the FCC. They're doing much better. They're doing much better. Okay, let me give you one for instance, the 25-year rule. And for the ones in the audience who haven't heard of the 25-year rule, Azita brought this up, that when you finish with your satellite mission, you have to show that you can remove it within 25 years at the end of your mission. So why is that good? That's really bad, by the way. 25 years. 25 years is 5 generations of spacecraft at this point in low Earth orbit. So if you unpack this, there's two things. One is there's a model that they like to show. Let's look at 200 years using the 25-year rule and 200 years of using the 5-year rule, and look at the low Earth orbit environment after 200 years. And what the models show, remember, all models are wrong, some are useful. What the models show is that after 200 years, the 5-year rule, which means you have to put it at 500 kilometers versus 25-year putting it at 650 kilometers, it only changes the total amount of debris and trackable debris in low Earth orbit by 10%. So instead of growing by 110%, it grows by 100%. So it's not worth it. Well, here's the problem. The amount of trackable debris after 200 years doesn't help the safety of the constellations below 700 kilometers. You can have breakups every single year. The debris would not proliferate, but they knock out those constellations of satellites. So that definition of goodness of a metric, I believe, is flawed, because it doesn't really keep you safe. It keeps you sustainable, but doesn't keep you safe. The second thing is, if you look back at the documents that were used to justify the 25-year rule, there's a document done in 1997 by Robert Reynolds and Peter Eichler and Nick Johnson. It said it would take a 5% mass margin to adhere to the 25-year rule. Mass margin is the percentage of the mass of a spacecraft that had to be fuel. So basically, You had to launch a spacecraft and 5% of the mass would have to be fuel. They didn't want to do any more than that. And that was one of the reasons why the 25-year rule seemed to make good sense. Not the only reason, but one of the reasons. Well, guess what? We did a paper recently with Aerojet Rocketdyne, and we showed that you could do a 1-year rule. A 1-year rule is put it a little bit below 400 kilometers. A 1-year rule with any size of spacecraft in low Earth orbit if you use electric propulsion rather than chemical propulsion. So that 1990 standards of chemical propulsion of an ISP of 2 to 300 has now changed, but the guidelines have not moved forward with it. Guess what OneWeb and SpaceX and Kuiper and Iridium are using? They're using electric thrusters. So my answer was very controversial and very confrontational, but do the right thing. Don't follow the guidelines, because the guidelines I don't think are keeping pace with the congested nature of the space environment and the technologies available to us. So there's an easy segue.
Thank you, Darren. Sean, do you want to pick up the ball there and talk a little bit about kind of your views on what it is that we need to be communicating among space operators, or what do we need from other space operators to continue to operate safely?
Sure. Well, I'll take a whack at that one. I think so. I do agree with what Darren said about some of these rules. The 25-year rule, right? That's of marginal utility, I think now. I think what's more important is to make sure that people who are putting things in space are equipping themselves properly. So we want to make sure that they've got adequate deorbit capability, that it is certified in a way that we really believe in. We also want to make sure that if they go belly up, of which there is a not insignificant chance that may happen while their objects are on orbit, that there is some process and some procedure that allows us to whereby people are both regulatorily and economically incentivized to bring that satellite back down safely. So we need to think hard about that. And then we need to think about other kinds of equipage that I think we would want to have. So, for example, it goes without saying we would want people to be shielded to the extent that it makes sense economically. And what we decide that number is, I think a lot of people have advocated 1 centimeter size objects. They should be shielded against that size of object so that they won't be taken out by that and that they'll suffer minimal damage. That seems like a sensible thing to require people to do. We should ask them to choose low density orbits. This is something Darren kind of touched on earlier. Don't go to 850 kilometers. Go someplace where it's safe. We should also ask them put on good transponder capabilities. Put a GPS transponder on your satellite. Oh, by the way, perhaps you might want to add, somebody actually just suggested this to me today, and I think it's a great idea. Put it on a different battery system. So if your whole satellite goes out, you're still telling everybody, this is where I am. Because, it's the dead things that don't tell us where they are that are the worst things of all. And finally, maybe we should actually ask them. I think I even saw a question about this about putting up, satellites with corner reflectors. And the answer is to that question, by the way, is we do. We already put up calibration satellites, but it's actually a good suggestion. That would be another kind of way of ensuring our ability to see clearly satellites that had perhaps died, but get sort of precision information on them through ranging and other means that would allow us to track them even after they've perhaps gone belly up. So that's just I think there's a number of actually suggestions people have come up with, but that's kind of a minimal set, I think, that I've sort of voiced right now.
Thank you. Kevin, do you mind jumping in on this one now, please?
Sure, and I'll probably revert back to a couple of things that came up before, but I think the first thing we need to see, and we're seeing it, is the larger community being witting of this problem. When I first got to Commerce, people said to me, industry doesn't give a care about space safety. And if you thought about that for 30 seconds, you realize how silly that comment is. Most are, but increasingly we're seeing other communities interested in this as well. The space finance community, I've had a couple of awkward conversations with finance people to say, hey, you own this problem as well, because it's your dollars that are at risk. And so whether you're investing in any kind of a space startup, which have a lot of things to worry about technically and otherwise. This has got to be a piece of the story. Or there's an entire community that we're calling the space safety industry that you ought to think about from an investment perspective as well. So the circle of people who are worried about this is a lot larger. Second, to the point made by both Darren and Sean about the regulatory environment on this, obviously pushing very hard to modernize that regulatory environment, but it's critical. Industry is going to set practical standards in this area. I keep seeing out of the corner of my eye, I keep seeing the word norms pop up in some of the questions, and the diplomats are going to have their discussions, and they should have their discussions. We've just had a UN COPO session that was fairly successful, and so in the meanwhile, it's industry that is going to develop these practical standards. For those of you that went to Amos or got a chance to look at the Amos videos, Dr. Ruth Stillwell had a brilliant example of using walking as a metaphor for space safety. And if you can't understand that one, well, I don't know what you can do. But the extent to which industry is going to have practical ideas about how to do this, about organizations like Confers, some of the other international standards discussions that are going underway. Those have to be part of the solution, even as the longer term bodies think about these things. And so that's really important. Second point I'd hit on, and it comes back to the last question, the question of releasability of data. You all know that the Department of Defense has been very vocal about wanting to get out of the piece of the mission having to do with notifications. It's not getting out of the entire mission. And so I'm focused less on the releasability of data as opposed to why we were justifying an open architecture approach. Because in an open architecture approach, number one, you got to bring a crush of data in from civil and commercial partners. You got to apply modern data science and analytic techniques in a way that just cannot be done on the DoD side. And it is also able to adapt as the space environment changes. We're so often focused on the mega constellations as the source of concern, but the reality is, as we do orbital transfer and RPO, that adds a level of complexity that really takes the math to a whole new level in this area. And so the open architecture approach was really used to think about that. Now, that said, to a point that Sean made a few minutes ago, it has to be a trusted architecture. And so, someone has to play a role in terms of looking at validating data that is in there. And again, modern data science techniques allow you to do this very flexibly, okay, to be sure that you have cyber hygiene associated both with individual inputs, but also for the integrity of the entire system. Because what has to come out has got to be trusted by all parties, actually. So I think the emphasis is less on the releasability of data on the other side of the fence, where I think we're going to continue to see things come across the transom, but really to take advantage of a modern, rigorous scientific approach to this problem using data on the outside, such as Darren has described and a number of other companies have as well.
Great, thank you. So I think it, oh, go ahead, Sean.
Right.
Well, I just want to ask one follow-up on one thing that Kevin had mentioned about the financial world. So one thing we've always wondered about, and I'm curious about your perspective on this, is there's some questions that have rolled by about the Kessler effect. And what I've always wondered is, why isn't it going to be the case that we're going to have sort of a financial Kessler effect with the next one or two bad incidents in space, where the financial people are the ones who end up shutting down or perhaps even changing a lot of the activities in space because they just decide, well, there's too much risk there, and I don't want to be operating under this umbrella of risk.
Well, I think individual investors will gauge the risk accordingly. I think that's partly why we've been spending some time trying to explain to them what the nature of the problem is and why they have a role in helping encourage the solutions. Frankly, even before people get off the ground, in addition to government regulation and things like that. And so they've taken it on. I mean, there's some trepidation about it when you call attention to it, but they will include that risk in the way they think about it. But I take your point of financial Kessler effect. That's an interesting idea, actually. I'm not as worried about it I'm also not as worried. This has become much more of a normal market. Again, we'll all remember the days 20 years ago when someone said, "Well, if GOI or whatever, if their assets, if the company goes out of business, what will happen to their assets? What will happen to their archives? Other things they're required to keep by law." Today, we're in a world where the breadth and depth of the space economy is so broad and large that there will be ways to deal with that on a purely commercial basis. And obviously, where necessary, the government would block the transfer of those kinds of assets to someone we'd rather not have them. So I think the market size here is actually reflective of maturity that is really good to see in this area.
Darren.
Just since this Kessler syndrome was mentioned a couple times, I want to remind people, since Don is a good friend of mine, we talk about this often. The critical density for the Kessler syndrome to come into effect was surpassed in the mid-80s at certain altitudes. So what's the big deal? The real issue is what's the timeline, right? Remember, Don was a person who looked on micrometer, look at how the moons around planets broke up over time to make the rings around Saturn. We're talking many, many thousands of years. So the real question is, how much past the critical density will shorten that timeline? Okay, so I'll tell you, the Kessler syndrome is going to happen in 14,000 generations for sure. But if we keep doing what we're doing, it's going to happen in fewer generations. And the biggest issue that we have right now is it's much like, I think Azita or somebody brought up looking at global warming, or excuse me, climate change. So I don't get political here. Climate change. And that is, there are precursors to the fact that we're going past a tipping point. And the precursor that you don't hear about much is what Don and I have called the mini Kessler syndrome. The mini Kessler syndrome is you would expect many more satellites to be failing from mission terminating events before we have a cascading of catastrophic collisions. That's one reason why I work so hard in looking at spacecraft anomalies and tagging them. And Azita mentioned Mike Squire from NESC. He's been a big part of that community because that really is a precursor to an indicator that we're going to get this sort of cascading effect. And so it's really important for us to understand this dynamic nature and why when satellites just fail for no good reason, we don't ignore that, because that's going to be the canary dying in the coal mine that's going to tell us the next thing is coming. So we try to keep track of those things also as an overall assessment of the trends going on in space.
Thank you. Yeah. So I'm going to try to weave in a couple of our audience questions here as well. We've had some good things coming through on the chat. And maybe as we start to think about this next question, we can also talk a little bit about the kind of inherently international nature of the space domain. And while we may regulate and set standards here in the United States, there are alternatives to U.S. launch into space. So curious about thoughts, and we've talked primarily about collisions of a physical nature, but there's also the question of spectrum management in space. And so how do we think about spectrum management as it relates to our ability to control our craft and our ability to maintain the domain? Sean, do you mind kicking that one off for us with a couple of thoughts on the spectrum?
I'll give you my thoughts. Of course, it's funny. Spectrum is the one area where we do have some reasonably robust regulation, right? The FCC is the licensing, really the one license roadblock that stands between most people and getting up into space. And of course, that's primarily what they're interested in. They want to avoid spectrum collisions. I think my impression, because this is not necessarily my area of expertise, my impression is they have a reasonably good handle on that particular part. Perhaps the part where there are more challenges is the more inadvertent kind of interference, the one that was described by our speaker earlier. Putting up satellites, they're causing interference with optical observations. The transmissions from satellites might leak into radio astronomy, certainly I can imagine that being a concern. I think my general feeling on those is that we will find ways to mitigate those things, and that we also have options in terms of moving surveillance further into space. That so there's a number of options in that dimension. I think better data processing, and also just better just think of all the advances we got with putting the Hubble Space Telescope up in space. There's lots of reasons why you want to get off the Earth to do your space observations. So I think that will probably, some combination of those things will be the answers to those problems. Those are my thoughts, Ben.
Yeah. Kevin, do you mind jumping in with your thoughts on kind of the international and maybe with the spectrum flavor to it?
So on the spectrum front, this is another area of congestion. And again, all parties, absent the actors that Sean was referring to a few minutes ago, all parties have an interest in making sure that they're able to communicate, all over the place. And so, I think that's relatively well in hand, but it's an area that we need to pay attention to. It was part of SPD3, obviously. On the international front, we saw tremendous interest by our allies and partners in what was happening. DoD had a strong legacy of work on the defense side and was going to keep that legacy of partnerships for military to military relations and things like that. We had started down the path with a wide range of allies, the Commonwealth partners, the EU SST, Japan, and even others, to really talk about the civil and commercial aspects of this. Very, very engaged, very, very interested, not political or philosophical discussions about what kinds of capabilities different people could bring to bear to move on this very, very quickly. And so I think that's a very important component of this. Again, this is such a fast-moving industry that the extent to which we're learning from industry practices and even those of our civil partners, very, very important relative to the discussions that will go on at a higher level about governance and things like that. Also need to look to other countries for what they're doing in the way of laws, regulations, and policies as well. That's an important space to keep an eye on.
Thank you.
Sure.
Darren, maybe I'll direct the next one your direction first, and then others can chime in if they'd like. When we talk about non-U.S. space industry players and foreign government, how have you seen the cooperation level, and what do you think we need to do in terms of more international norms, kind of from your perspective?
Yeah, that's a great question, Ben. I'm glad you asked that, because I think oftentimes we like to be a little bit arrogant that we're Americans, we're out leading the way. And I think in many ways we are. But when it comes to the whole idea of space debris management, and that's both mitigation and remediation, I believe that we have been leaders in putting the mitigation guidelines, even though we haven't been updating them. But we have really been woefully poor leaders when it comes to debris remediation, active debris removal. European Space Agency and JAXA have both set up programs for operational active debris removal because they feel it's important. They see the math, they see why it's important, and the U.S. government has not. Typically been the idea that, well, it's decades out and we can do R&D on ADR kinds of things, but operationalizing it's a bit early. And I really think that the key takeaway for everybody right now needs to be a balance between space traffic management and space debris management, which includes both mitigation and remediation. All three of those are important, and none of those can we do without having global cooperation. I think we're best at mitigation, we're behind in remediation, and space traffic management is just a wild, wild west.
Thank you. Kevin, do you or Sean want to jump in with the?
Yeah, let me come back to that a little bit. Active debris removal was always a tool in the toolkit. I talked about this in my July testimony. It's always been one of the tools in the toolkit. I think the argument has been it has been the more expensive, if you will, of the options. And what we're seeing now, again, credit to Astroscale and ClearSpace and those governments for encouraging the active debris removal efforts that are already underway. we're starting to see in the United States, we're starting to see a wide range of companies trying to bring less expensive capabilities into the market. Obviously, some of this still requires some R&D to see what the most effective, someone asked a question about that a bit ago, what are the most effective techniques for bringing debris, pushing it out to the graveyard orbits or to bring it back to Earth, so we're still in the early stages of it, but I think folks are working on lower cost solutions to make it a more balanced part of the portfolio, if you will.
Before Sean answers that, Ben, I'm going to respond to Kevin. It's expensive, but pay me now or pay me more later.
Sure.
Right? And so 2007, I wrote a paper about this situation, about how we're likely to wait, right, to do that. And so I'm concerned that we're on the sidelines a bit. And Kevin's right. Some industry in the U.S. have started to try to pick up, but without government support. And so we look to our Swiss and our Japanese thought leaders when it comes to that. So sorry, Kevin.
So what incentives do you think we need to try to refocus some of those efforts?
So I believe, and I'm the last paper we just finished that we accomplished actually in 2019 with 13 people from 13 countries represented, 19 experts to look at the top 50 objects that need to be removed from space. What I think needs to happen is the 5 major spacefaring organizations need to catalyze the ADR industry. The government catalyzed launch before it became commercial. We catalyzed Earth imaging systems before it became commercial. We're not going to directly go into commercial active debris removal. I believe it's really the major spacefaring agencies, the 5 that really have contributed to the debris population, to do that catalyst. And we're going to put out a paper or an op-ed that calls for them to collectively remove 10 to 20 objects. We have a list that was put together by experts from 13 countries around the world, called the Top 50 paper. I think that's the only way we're going to go going, because otherwise we're going to keep going. We can commercialize it. We need a little kickstart like every other major spacefaring component. The government's always had the leadership to jumpstart it. That's my opinion.
Thank you. Kevin, Sean, do you have thoughts on that?
Well, I was just going to say, I certainly agree with Darren. I think he makes a compelling case about, let's go out and grab the big objects first. Let's really prioritize that, because those are the big debris generating capabilities that sit there. I do think we need to focus on, especially with the numbers of satellites that are planned to be put in orbit, we need to be focused on how do we get those folks to equip themselves in the ways that I think would be most beneficial to everyone. And, I think there's just a number of opportunities. We've talked about that there. And finally, I think, there's some pretty good examples that I've talked to folks about related to the openness discussion that we had earlier about data. I think there's another value of the DoD being a little bit selectively open about things that we understand are going on, because there's actually been some cases recently where we've been more open than we have in the past about plans that some of the other powers have to carry out experiments in space, experiments that we thought were risky, and we were more open about it, and took those concerns actually to social media and other places, and actually engaged in discussions with those folks, and in one case talked them out of doing the planned experiment. So I think there's a lot of things that could be done to really help this whole process. Darren has touched on a bunch of them, and Kevin has talked about some as well. And I think we should be pressing forward on all fronts. Great,
thank you. All right. So at this point, I want to extend my sincere thanks to Kevin, Darren, and Sean for the great discussion today, and welcome Charles Clancy back to wrap up for us.
Great. Thank you so much. It was a fascinating panel. Thank you to the panelists for such a great discussion, and Ben for moderating. Just a few wrap-up comments. First, I'll note that we have our October Power Hour coming up as well. It'll be on October 14th, same time, 4 p.m. Eastern. This one's going to be focused on biopreparedness. So please join us. It's going to be a great discussion. Second, beyond just our Power Hour events, we also have some other publicly facing events that people may be interested in, to include our new Distinguished Scientist Speaker Series that will be taking place on Wednesday of next week, 4 to 5 p.m. Eastern on September 29th. There, our guest speaker will be well-known theoretical physicist, Professor James Gates, who will talk about the important role that physics plays in a whole range of innovations from satellites to quantum computing, and talk about his experiences working as a physicist. The event will be hosted by MITRE fellow Dr. Jerry Gilbert, who's also a theoretical physicist and is leading a major quantum computing program here at MITRE. So with that, again, thank you to Azita for such compelling opening remarks, to our panelists, and to Ben for moderating.